Today we're going to go over the review for metric system, scientific notation, calculations, and the tile lab. Page 1 are conversions to scientific notation. These are the same conversions that you saw in the PowerPoint notes. 230. We need to move our assumed or presumed decimal point over 2 places, and we get 2.3 times 10 to the 2. We didn't include the other 0 because this 0 is not significant. All of these numbers are significant. We need to move our decimal point over 3 places, so we have 5.601 times 10 to the 3. In this number, only the first 3 places are significant. The 2 zeros are not significant because there's not a line over them, nor is there a decimal point over here. So we need to move our presumed decimal point over 1, 2, 3, 4 places. So this becomes 3.84 times 10 to the 4. Here we need to move our decimal point over 2 places to the right, so we have a negative exponent, 4.4 times 10 to the negative 2, because we moved it over 2 places. Here, none of these zeros are significant, but the last one is, because it's shown where it's not necessary. So we need to move our decimal point over 1, 2, 3, 4, 5, 6 places, 1.20 times 10 to the negative 6. The last one, these zeros are not significant, but all the rest of this number is. Again, it'll be a negative exponent, and we need to go until we have one number to the left of the decimal, so we need to go 1, 2, 3 places. So we end up with 1.002 times 10 to the negative 3. Next, we're going to convert from scientific notation back to standard decimal notation. 1.5 times 10 to the 3, we can write our 1.5. We move our decimal place 3 to the right. So 1, 2, 3. We don't write a decimal place because only those 2 numbers are significant. If we actually put a decimal point there, then that would make these numbers appear to be significant, but they're not. The next one, 1.5 times 10 to the negative 3, we can write our 1.5. Our decimal point needs to move over 1, 2, 3. So our decimal point is here. We'll put another 0 there. This number written more neatly, 0.0015. The next one, 3.35 times 10 to the negative 1. This negative 1 means that we need to move the decimal point over by 1 place to the left. So we end up with 0.335. This number we need to move 5 to the right, so we start with our 2.2, move over 1, 2, 3, 4, 5. To fill in these zeros. So end up with 220,000. Remember, only these 2 numbers are significant. The zeros are not, so there's no decimal point in there. That is a comma. The last one, 4.0 times 10 to the 0. 10 to the 0, anything to the 0 power, is equal to 1. So 4.0 times 1 is just 4.0. On the next page, we have some addition and subtraction. If you were in my class, you may have gone over some of these in class. But we have to make sure that the powers are the same. This power and this power are not the same, and we need to make them the same. So what I'm going to do is I'm going to raise everything to this power, to the 6th power, and I can do that by taking this and moving the decimal point over by 1, and that will allow me to raise this up to 6. Now I have 9.70 plus 0.83 times 10 to the 6. If I add these two numbers together, I end up with, let's see here, need a little more writing room. I end up with 10.53 times 10 to the 6. I need to convert this into appropriate scientific notation by moving this decimal point over by 1. That will cause me to raise this up. So my final number is 1.053 times 10 to the 7. Alright, the next one, 1.33 times 10 to the 5 minus 4.9 times 10 to the 4. I'm going to raise everything to the 5 power, so I need this to move over by 1 point, which allows me to raise this to 5. I now have 1.33 minus 0.49, and all of that is times 10 to the 5. I perform this subtraction and I get 0.83, or 84, pardon me, times 10 to the 5th. This isn't proper scientific notation. I need to move the decimal point over 1. When I do that, that's the equivalent of multiplying that by 10, so I have to divide this by 10. So I end up with 8.4, that is an 8, times 10 to the 4th power. Next, we have 3.67 times 10 to the times 10 to the 2 minus 1.6 times 10 to the 1. I want to raise this up to the 2nd power. I do that by moving my decimal point over by 1. Now, if I can get my pen back, I have 3.67 minus 0.16 times 10 to the 2. This number right here becomes 3.51 times 10 to the 2. And I have no need to change that at all. It's perfectly fine the way it is. Next we have 6.91 times 10 to the 2 plus 2.4 times 10 to the negative 3. I want to raise this up to the negative 2 power, which I can do by multiplying it by 10. That means I need to divide this by 10. I move the decimal point over. Notice I'm being consistent in moving my decimal point over and raising my power so that both of them have the higher power. That's just my personal preference. You can lower one to the lower power if you'd like as well, but I like to be consistent so that I don't forget and go the wrong way. Now I can add my coefficients. 6.91 plus 0.24, and all of that is times 10 to the negative 2. When I add these together, I get 7.15, point in there, times 10 to the negative 2, and I'm done. I don't need to make any more changes. Almost done here with this page. 8.41 times 10 to the negative 5 minus 7.9 times 10 to the 6. I want to raise this up to negative 5 like the other one, so I have to move that over by 1. And I have 8.41 minus 0.79, and all of that is times 10 to the minus 5. When I perform the subtraction on these coefficients, I get the number 7.62 times 10 to the negative 5. Again, that number is proper scientific notation. I don't have to do anything to it. So that is the correct answer there. And our last one, I have 1.2 times 10 to the 5 plus 5.35 times 10 to the 6. 6 is our larger power, so I'm going to raise this one up to 6 by moving the decimal point over on this side. So I end up with 0.12 plus 5.35, all of that times 10 to the 6. When I add those together, I get 5.47 times 10 to the 6. And again, I don't have to do anything to that. That's a final number. Moving on to the next, we're going to do some multiplication. Remember that with multiplication, we can multiply the significand or the coefficient, and then we add our exponents. So we end up with 1.5 times 8.0 times 10 to the minus 2 plus 8 minus 1. When we perform our multiplication here, we end up with 12 times 10 to the minus 3. Notice I didn't say 12.0. I have two significant figures here and two here, so I need two here. But one of the problems is this is not correct scientific notation. I need to move my decimal point over by 1, and when I move that over by 1, that means I'm going to have to increase this number by 1, and increasing on my number line from negative 2 is, or from negative 3 is negative 2. So my final answer is 1.2 times 10 to the negative 2. The next one, 4.3 times 10 to the 8th times 2.0 times 10 to the 6. 4.3 times 2.0 times 10 to the 8 plus 6. Well, 4.3 times 2.0, that's just 8.6 times 10 to the, well, 8 plus 6 is 14. So that's our answer right there. Don't need to make any changes. Our last multiplication problem here, 6.0 times 10 to the 3 times 1.5 times 10 to the negative 2. So we have 6.0 times 1.5 times 10 to the 3 plus a negative 2, which is just 3 minus 2. Six times 1.5 is 9.0 times 10, 3 minus 2 is 1. Now this number is the same as 90, but notice how significant figures show that we have two significant figures here. Whereas if you read 90 right here, you would only presume that it had 1. If we wrote this in decimal notation, we need to either put a decimal point there or a line over that to indicate that both of those figures are significant. Next, we have 8.1 times 10 to the negative 2 divided by 9.0 times 10 to the 2. You're going to see that you can actually do this one in your head, even though it doesn't look like it right now. When we do division, we can divide the first numbers, and then we subtract the exponents. So let's do the division. 8.1 divided by 9.0. This actually you can do in your head. If this had been 81 divided by 9, we know 9 times 9 is 9, or 9 times 9 is 81, rather. So 81 divided by 9 would be 9. Since we've had to divide this by 10 to go from 81 to 8.1, we could divide that answer by 10. So this is really 0.9. For these, we're going to take the top number and subtract the bottom number. So it's times 10 to the minus 2 minus 2. We end up with 0.9 times 10 to the minus 4. Now this is not quite proper scientific notation. What we have to do is move our decimal point over, and when we move it over to the right, that means we have to reduce this by 1. We end up with 9. This really should be 9.0. Should have had a 0 in here because we have two significant figures in this, so we need it in our answer. 9.0 times 10 to the negative 5. Our last one on this page, 7.8 times 10 to the 3 divided by 1.2 times 10 to the 4. 7.8 divided by 1.2 times 10 to the 3 minus 4. 7.8 divided by 1.2 is 6.5 with our two significant figures, times 10 to the 3 minus 4 is just negative 1. So this is our final answer. Moving on to the next page, we have a long one. Here we can again manipulate just the front of these numbers. So we end up with 6.8 divided by 2.4 and also divided by 1.8. All of this is times 10 to the, well, we'll start with 5, then we'll subtract the 4 that we have on the bottom, and we'll also subtract the negative 2, minus a negative 2. So that becomes a plus 2. Okay, so this number right here is just 1.5 times 10 to this power. 5 minus 4 is 1, plus 2 is 3. So this is 1.5 times 10 to the 3. Moving on to the next page,